In this lesson, I'm going to introduce you to something called function notation. So, suppose you have several functions and they all start with y. Y equals 2x plus 1, y equals 3x minus 4, y equals x plus 5. So, the problem is that they all say y. So, if I plug something into them, I just get an answer out that says y equals 7, or y equals 9. And it's not obvious which of these was used to get it because they all have the same name. It's like having three guys in a room named Bob. If you say Bob, they all three turn around and look at you, so you need a way to tell them apart. Because each answer is a y value, it gets difficult to keep up with what function was used to create a certain y value and what x value was plugged in. There's no way to keep up with all of that. So function notation solves that problem. And here's how it does it. Let's take a look at our three functions again. Now, instead of calling this one y equals 2x plus 1, let's give it a different name. I know that whatever I put here still has to represent a y value for my ordered pair, but I can call it anything I want. So since we know this is a function, let's call it f for function. And something else we're going to do is in parentheses next to the letter f, we will put x in parentheses. So this now says f parentheses x, or actually when we read it, we say f of x. I know it looks like f times x because of the parentheses, but it's not. The x is not something to multiply. The x is part of the labeling system. So f becomes the name of our function, and x becomes a placeholder for whatever you're going to plug in. And also it lets the reader know that you consider x to be a variable. And if the value of x changes, it will change here as well. Okay, so I've labeled this one f of x, and now I'm going to label this one, may as well call it g of x. And now let's label this one h of x. So f is a very common function name because f stands for function. But, and you know, g is a very common name because that's what comes after f. H comes after g. But really there's nothing magic about these letters, and you could use any letters you wanted to for your function names. Okay, so just a reminder, f of x, or f parentheses x, stands for f of x, not f times x. Now let's evaluate f of 2. Now what that means is we will take the letter x out of here and replace it with a 2. See how the 2 is in the place of the x? That means I should use this function, and the x should be replaced with a 2. So now instead of 2x plus 1, it will say 2 times 2 plus 1, which will be 5. And let's also evaluate f of negative 3. So this tells me that I'm going to use the same f function, but I will replace the x with a negative 3. So now instead of 2x plus 1, it says 2 times negative 3 plus 1. 2 times negative 3 will be negative 6. Negative 6 plus 1 will be negative 5. Now let's do g of 7. So this is telling me to use the g function and to replace the x with a 7. So instead of 3x minus 4, I will have 3 times 7 minus 4. 3 times 7 is 21, and 21 minus 4 is 17. Now we can even plug expressions into a function. Let's take the function f of x equals 5x minus 7. And let's evaluate it at f of x plus 9. So we'll evaluate the function at x plus 9. So you see the x plus 9 in parentheses here. And what that means is the x plus 9 is replacing the x. So in my function, where it used to say x, I will now put in x plus 9. So instead of 5x, it says 5 times x plus 9, minus 7. I should distribute. So I have 5x plus 45 minus 7, and then I should combine my like terms, so I get 5x plus 38. Let's also evaluate f of 2x minus 6. So in this case, 2x minus 6 goes in the place of x, and instead of 5x minus 7, I will have 5 times 2x minus 6 minus 7. So again, distribute your 5 and combine your like terms, and we'll end up with 10x minus 37. Okay, here is our first quadratic function. Let's let f of x equal x squared minus 3x plus 6. So we'll evaluate each of the following. First, let's do f of 3. So I will replace the x in this function with a 3. Instead of x squared, it will say 3 squared. Instead of minus 3 times x, it will say minus 3 times 3. And then the last term is plus 6. We go back and evaluate each term. 3 squared is 9. Negative 3 times 3 makes minus 9. The last term is plus 6. 9 minus 9 is 0, and 0 plus 6 is 6. Okay, now let's evaluate f of negative 5. I will replace the x in my function with negative 5. So the first term says negative 5 squared. The second term says negative 3 times negative 5. And the last term says plus 6. Negative 5 times negative 5 makes positive 25. Negative 3 times negative 5 makes plus 16, or plus 15 rather, and the last term is plus 6. 25 plus 15 is 40, and 40 plus 6 is 46. Okay, let's now evaluate f of x plus 7. So I will replace the x in my function with x plus 7. Instead of x squared, it will say x plus 7 squared. Instead of minus 3 times x, it will say minus 3 times x plus 7. And the last term is plus 6. So this takes a little more work to multiply out. We've talked before about how to square a binomial, so we need to do that now. The first term will be x times x, x squared. The middle term will be 7x times 2, which is 14x. And the last term is 7 times 7, which is 49. Now distribute your negative 3. We get negative 3x minus 21, and keep our plus 6. Let's go back and combine like terms. We have x squared. Then for my x terms, I have 14x minus 3x, which is 11x. And for my constant, I have 49 minus 21 plus 6, which makes plus 34. Okay, now let's do f of x minus 1. So we will be replacing the x in our function with x minus 1. So instead of x squared, it now says x minus 1 squared. Instead of minus 3x, it now says minus 3 times x minus 1. And then the third term is plus 6. So you see, all I'm doing is taking the x out and putting in the x minus 1 because that's what is here. Okay, now same thing. I have to multiply out the x minus 1 squared. That will make 3 terms. First term is x times x. The middle term will be negative 1x times 2, so negative 2x, and last times last is going to make plus 1. Now distribute your negative 3. Negative 3x plus 3, and there's your plus 6. Okay, now combine your like terms, you get x squared. Negative 2x minus 3x, you get negative 5x. And 1 plus 3 plus 6 gives you 10. So x squared minus 5x plus 10.